Hey everyone, in this demo live stream, we are going to be doing a simple MCP Python server just running locally using the standard input output protocol. So this is, just if you want the server to run locally, not for anything that you're going to be running off a server over HTTP. So I'm using this repo here, Pamela Fox MCP Python demo. And I'm just going to look at the code in that. So let's start off with the demo. So a lot of times when we're getting started with MCP, what we'll do is run the MCP development inspector on our server, because usually we're developing a server, and this dev inspector makes it easy to see everything that our server exposes. So it has started up the server, and we need to grab the session token from the terminal here and put it in the configuration, and then we can connect. So you can see it's just using UV over standard input output to run my server.py file. So we're going to say connect, and now it's connected. And up here we can see that the MCP server can have resources, prompts, tools, ping, sampling, routes, and auth. So for this one, I think we only have prompts and tools. So we can list the prompts. So we have two different prompts here. And with each of these prompts, you can basically enter variables in for the prompts. So you could think of this as prompt templates, right? So you'd enter the variables. And then we have tools. And that's what most people think of when they think of MCP are the tools. So let's go ahead and look at the tools. We have add list of numbers, very exciting tool, right? So we can go and we can click on a particular tool, and that'll give us a UI for trying out the tool. So in this case, it knows that the tool takes a list. So it gives us a UI for adding list items. So now we've got the arguments, and we can send that to the tool and then get back the results. So it tells us, here's the numbers, here's the sum, here's the count, here's the average, here's the min, here's the max, here's a summary, everything you could always want to know about a list of numbers. We could also use JSON for inputting those arguments as well. But basically we have our input, we have our output. Then we have count letter in text. This is for the classic counting the number of R's in strawberry. And then we get back the responses. And then we have something that's more like what you might want to actually do, which in this case, we're running Azure CLI commands. So I could do, AZ group list and list all of my Azure resource groups. And so this is actually running on my system, which is logged into an account. So it should be able to work. Oh, the request timed out. That might be because I just restarted my machine. So I wonder if we need to do another relogin. So let's go ahead and try this here. AZ group list and see if this succeeds when we're running it locally as well. Okay, so that one did succeed. It did take a little bit of time. All right, and this time it worked. So there we go. Now what's interesting, let's say if I try to do like AZ group create and give it like a name, my name, and then a location. I think that's the syntax for it. And we run this command, and it says, and this one succeeded as well. Okay, that's interesting. The reason I think that's interesting is because I thought that we had a list of allowed operations and not allowed operations for this tool. And let's check it out. Because here's the thing, as soon as your server can run commands on your machine, you want to be careful about what sort of commands you can just casually run. So let's look at the code now and see what our code actually allows. So we look at code here, right? So we have prompts. So we're using the fast MCP package. The prompts are basically just, strings that take in template variables. So that's our prompts. And then we have the tools, right? So this tool is the number addition tool. It takes in a list of ints and it returns back a dictionary. This tool takes in a text and a letter, returns back a dictionary. And then here's that Azure CLI tool. which just takes in a string and returns back a dictionary. And here's what we did. Okay, we only allowed some commands. So we allowed version, account, group, resource, storage, VM, web app, SQL. And we also checked for dangerous characters, tried to parse the command, checked if it's an allowed commands. So we did some amount of processing to see if we were comfortable with it. If we wanted to make this even like safer, what I would do is only allow read only commands, right? And say like, okay, read commands are fine. Any sort of write commands are not fine. Now that would mean we would need to have a list of what the read commands were versus the write commands. So that would be, more work to come up with that list. But I think generally a nice approach is to say like, okay, usually reading is fine if it's just you personally, right? Writing is a lot more dangerous. Now, reading can also be dangerous if someone else gets access to that. And we've seen that happen with MCP servers being used like kind of behind the scenes from agents, and then they expose things that other people aren't supposed to know. So even reading anything, anytime you're dealing with anything that's logged in, it's a security issue, right? So it just depends how you're using it and what you want. But anyway, the point of today isn't necessarily security. It's just to, look at how you might develop an MCP server with Python locally. So that's the server. We verified it's running there. And then what can we do with it? Well, then we can install it in various tools, right? Any sort of MCP host or client that we have, we can install this server. So if I go and say MCP install server.py, then that's a command that will update the Claude configuration. So now let me restart Claude, and I will show you the configuration in the settings here. So you go to settings, developer, my app. You can see that it's using the UV command and using that to run the server.py. So it's got that MCP server installed. And so then we can say, okay, well, so how many R's are in strawberry, right? And, we know that LLMs are not very good at answering that question. But luckily, it has a tool it can use. So it says Claude would like to use an external integration. And it says, here's the tool. And we can say allow always or allow once. So I'll allow that one always. And we can see what arguments the LLM decides to send to the tool, right? So that's what we're using the LLMs for, is to look at the tool definitions, look at the tool inputs and say, okay, to answer my question, I'm going to send these arguments to the tool. That's what the LLM is doing. And then, behind the scenes, the desktop application is calling that function. All right. And it answered the question there. We can try something a little fancier. Let's see if the Azure one will work here. I was having some issues with this when I tried it earlier, but we'll see. So in this case, what we're using the LLM for is to actually come up with the Azure CLI command, right? So I didn't tell it which command to run. I just said, hey, list my Azure resource groups. It saw that it had a tool that could run Azure CLI. It knows about the Azure CLI because it's been around for quite a few years. So it's actually in its weights. So in this case, we can actually use the tool to come up with the right syntax use the LLM to come up with the right syntax for that command. So it did come up with the right syntax. But then, it's getting some really funky errors. So I think there's something up with my environment, probably like a homebrew install thing. It's like running. It's running in something funky. Okay. Oh, it did figure out. I don't know how it got that, but it did manage to do AZ account show and figured out where I'm logged in. So it's attempting to do a lot of debugging. So there's something a little bit interesting about where it's running its commands versus my terminal. I think there's something off about my environment, but it's doing a great job coming up with the commands and trying to actually debug it on its own. It's being very agentic, which makes sense. It's the Sonnet models, and they're very good at agentic thinking or agentic operating. Okay, so now you got it in Claude. We could also install in GitHub Copilot. Or anything that is an MCP host. Now, we can also write our own client to consume the server, right? So here, if we're consuming a local standard input output server, then this is what our code looks like. We're going to use the standard input output client. We're going to tell it how to run that command, and then we'll set up our session connecting to it and say, okay, list the tools, and we can see the tools, list the prompts, and then we can actually call one of those tools with the arguments and get back the responses. So let me go ahead and run that code, client.py. All right, it's already done a bunch of the processing, right? So it looked at all the tools we had. Those are all the tools. It looks at all the prompts that are available. It actually calls them, each of them, and get things, and calls each of the prompts. So there we've done a thorough test of our server. So there's the idea, is that you can run a server, you can use that with local MCP hosts, you can debug it with MCP Dev Inspector, you can write your own client if that's useful for you. You can also use many agent frameworks that just know how to consume tools from a local MCP server. So there's a lot of options. But in this video, I just wanted to show the basic standard input output client server. In future videos, I'll show how we can do deployed MCP client servers where things get a bit interesting. All right, bye.